Okay, for lesson 5, we're going to be determining square roots and cube roots with prime factorization. So we're going to let prime, now that we've learned how to prime factorization, we're going to use that to help us identify perfect squares and perfect cubes. Okay, we can also use our calculator, but if they're perfect, there is a way to figure them out using prime factorization. So, some things to know. Any whole number that can be represented as the area of a square with a whole number side length is a perfect square. So for example, if I have 25, the side length of the square is going to be the square root of the area of the square. So if my area is 25, that means that each side will be equal to square root of 25, which equals 5. Okay, so the area is equal to side squared, right? So that means that this would be 5 by 5. It's a perfect square. Okay, so the side length of the square is literally the square root of the area of the triangle. Now the square root of n is, we use that square root bracket, and the square of this n, square root n, is equal to n. Okay, so basically, yeah, so that's that kind of relationship. Now any whole number that can be represented as the volume of a cube with a whole number edge length is a perfect cube. So for example, if I have the volume is 27, so the volume is 27, then that's equal to the side cubed. So what that means is I need a number that is will multiply to give me 27. Well, will cubed, right? So 3 times 3 times 3 equals 27, which is 3 cubed. So that would tell me that my side length here is 3. Okay, and we can write a cubed root in this way. So we would have the square root bracket, except we put a 3 in there, and basically that's what it looks like. So the cubed root of n is cubed root, we see this, and the cube of this cubed root of n is n. Now on your calculators, you put that in by going 3, and then there's a button that looks like this, and so you would use this to create this, and it would have an X there. Okay, I think that's what it looks like. Oh, it has a Y. It ain't an X, it's a Y. Okay, so say I was putting this in my calculator, I would go 3, I'm just going to try it out to make sure it works, 3 second function cubed root 27 equals, no, that didn't work. 27 second function. Oh, I go the other way around. Good thing I tried it. So to figure this out, I would put my 27, hit this button, hit 3, and then equals. And I should get 3 for my answer. Okay. Now, if we're exploring what all of these things mean, n would be our index, the bracket is our radical sign, and x is our radicand, whatever's underneath. Okay. All right. So how do we figure out cubed roots? Well, it says determine the exact cubed root if possible. So we can use our calculator, but we can also think about it. Okay, so looking at this, I have 3, the cubed root of 27. Now, I know that 27 is 3 times 3 times 3, so that means that this will equal 3, okay? Because I have it times itself 3 times underneath the radical. Now I have here cubed root of 1 over 216. 216 divided by 6 divided by 6. 216 is 6 times 6 times 6, right? So I can take that out. So this is like having 1/6, this is a 3, times 1/6 times 1/6, so it's 3 times, so this would equal 1/6. Now, cubed roots, we can have negative numbers under the cubed root because if I do this, it's -1 times -1 times -1. I could put them in brackets if that helps, and we would still get a -1, okay? Similarly here, negative sign outside, cubed root of -8 is -2 times -2 times -2. Because we're cubing now, so we're talking about 3 times multiplications, we can have that negative sign because they are going to, I can get a negative answer. So this would be a negative times -1/2, or -2. Negative times a negative is +2. Okay? All right. Now, your calculator can help you out a bit there, but we're going to do a method here using prime factorization to kind of help us and to show us how to do this. So, if I want to find this square root of 144 using prime factorization, so square, here I'm just looking for the square root, I'm going to be looking for pairs of multiplying. So I use my factor tree until I'm down to all my prime numbers, right? So I'm going to rearrange my prime numbers then into 2 equals groups. I have 2 times 2 times 3 and 2 times 2 times 3. Well, 2 times 2 times 3 is 12. 2 times 2 times 3 times 12. So that tells me that the square root of 144 is equal to 12. Okay? I always say if you look for pairs, because there's another way you can write this. I can write this like this. 2 times 2 times 2 times 2 times 3 times 3. Now I'm finding square roots, so I'm going to look for pairs. So if I have a pair on the inside, that will be worth 1 on the outside. So this will be 2 times 2 times 3, which equals 12. So that's another way you can kind of think of it. All right, determine the square root of 1296 using prime factorization. And yes, I know, you can use your calculator, miss, and it tells me, but we're going to use prime factorization to do it. 1296. So if I factor that, it's 9 times 144. 9 is 3 times 3. So those are prime numbers, so we can highlight those and say, oop, we're done. Okay. 144 is 12 times 12. 12 is 3 times 4. And 12 is 3 times 4. And 4 is 2 times 2. And 2 times 2. Okay, let's highlight our primes. I've got a 3 here, a 3 here, 2 here, 2 here, 2 here, 2 here. Okay, so if I sketch that out, 1296 equals, and I write all these out in pairs. 3 times 3, oh wait, I like to put them in order, right? Start with my 2's. 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Make sure I got the right number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now that they're in that order, it's easier to kind of see pairs. There's a pair, there's a pair, there's a pair, and there's a pair. So when I take those out, I'll get 2 times 2 times 3 times 3. I just take out one number for each pair because I'm finding the square root. So 2 times 2 times 3 times 3 equals If I multiply those, it equals 36. Okay, so you can use those to kind of help you use the factor tree, get to find prime factorization, and then you can solve. Determine the square root of 1764 using prime factorization. So we're going to do a right once 1764 is a product of its prime factors, and then rearrange into two equal groups or into pairs. Okay, so 1764 is 9 times 196. So this will be 3 times 3. 196 is 4 times 49. So 4 times 44 is 2 times 2, and 49 is my favorite multiplication, and I don't know why, but it always has been. 7 times 7. Okay? So we highlight our primes. 3, 3, 2, 2, 7, 7. It's kind of neat. It's already in, just happened that it is in prime number pairs right now. So 1764 is equal to, in order, 2 times 2 times 3 times 3 times 7 times 7. Now remember, we're finding the square root, right? So let's circle our pairs. 2 and 2, 3 and 3, 7 and 7. For each one of these, you're just writing it once. 2 times 3 is 6, times 7 is 42. And to check, you can go 42 times 42, and you'll get 1764. So this is our little check. Okay? All right. I like examples. This is new stuff. So we're going to do another example. A square has an area of 324 square inches. What's the side length? So if the area is equal to 324 and it's equal to side squared, then the side will be the square root of 324. All right? So let's do our prime factorization. 324 is 54 times 6. 54 is 6 times 9. And 6 is 2 times 3. 6 is 2 times 3 here. 9 is 3 times 3. Let's make sure we're all prime. 2, 3, 3, 3, 2, and 3. All prime. Now let's list them out in pairs in order. So we're looking for the square root of 324. So we have 2 times 2 times 3 times 3 times 3 times 3. We're going to circle our pairs, 2s, 3s, and 3s, and then we are going to get our answer. So the square root of 324 will equal 2 times 3 times 3, which equals 2 times 3 is 6, times 3 is 18. Okay, and again, it's a word problem, so you could write out the side length is 18 inches. Okay, and just do a little check. 18 times 18 does indeed equal 324. Okay, a check is never a bad idea. Okay, now we can use a very similar skill to figure cubed roots. Okay, the only difference is a cube means 3 multiplications, not 2. So we still do our prime factorization, except now we're going to look for trios, not just pairs. So here we do our prime factorization, we get our prime numbers, we list them out. Now I'm going to do them my way. Each prime factor appears 3 times. So if I write square root of 216 is equal to 2 times 2 times 2 times 3 times 3 times 3. If I look at it like this, there are 3, and oops, sorry, this is a cubed root, so I've got to remember to put my cube root in there. Sorry, and I get this. So now that's what's different here. So I just, for each trio, I'm just going to write one multiplication. So this will be 2 times 3, which is equal to 6, which is the same thing you would get the way they did it. Okay, it's just a slightly different way. Both are right, and both are going to get you to the right answers. You can use prime factorization to find your cubed roots the same way we did with square roots. So, determine the cube root of 1728 using prime factorization. So let's factor. 1728 is 9 times 192. 9 is 3 times 3. 192 is 12 times 16. So this will be 4 times 3. 16 will be 4 times 4. 4 is 2 times 2. And here we have 2 times 2 and 2 times 2. Now, I don't want to lose track of any of those prime numbers, so let's highlight them. 3, 3, 2, 2, 3, 2, 2, 2, 2. Got them all. Excellent. Okay, now we're going to list them. Remember, we're looking for the cubed root of 1728. So cubed root of, let's list them from smallest to largest. 2 times 2 times 2 times 2 times 2 times 2. I've got 6 of those. Times 3 times 3 times 3. Now let's circle our triplets, our trios. 3 2's there, 3 2's there, and 3 3's there. For my answer then, it's going to be 2 times 2 times 3. Just take 1 for each of those. 2 times 2 is 4, times 3 is 12. And if you want to check, 12 times 12 times 12 equals 1728. Okay? It's always good to do a little check to make sure we're on the right track. Now, I know we're doing both cube roots and square roots, so it's good to do another couple of examples. So I've got a couple more examples here. Determine the cubed root of 2,744. Okay, so 2,744. We're going to do prime factorization. So this is 7 times 392. 7's a prime number, so here 392 will be 8 times 49. 49 is 7 times 7, and 8 is 4 times 2, and 4 is 2 times 2. So let's highlight our primes. I have a 7, a 2, a 2, a 2, and a 7, 7, 7. I already can kind of see that I have triplets. So we're finding the cubed root of 2,744. So it's the cubed root of, let's write them in order, 2 times 2 times 2 times 7 times 7 times 7. Now let's circle our triplets or our trios. I'm going to get a 2 and a 7. So this will equal 2 times 7, right? Which is equal to 14. Okay, and again, you can check 14 cubed is indeed equal to 2,744. Okay, do the check. It's always a good thing. I think this is our last example. Yes, a cube has a volume of 4,913 cubic inches. What's the surface area of the cube? So, okay. Well, first, we've got some information there that the surface area is 6 times x squared, and x would be the length of the side, right? So we need to find the cubed root of 4913, and that will equal to a side length, okay? So let's do that, 4913. We're going to do our prime factorization. Now, looking at this, it's kind of weird. We're going to do a bunch of division, and, you know, 4913, it's not divisible by 3, not divisible by 4, not divisible by 5, but look at this, 4913 is divisible by 17. So it's 17 times 289. Wow. Now 289 is divisible by 17. It's 17 times 17. And 17, even though it's a huge, big number, it is prime, okay? So what that tells me is the cubed root of 4913 is equal to the cubed root of 17 times 17 times 17, right? So we circle our triplets. So that means it's equal to 17. And it would be inches. So that's a side length. Now that's just first part. The question actually wants us to find the surface, oops, that's not the right pen. It wants us to find the surface area of the cube. So we have to use this formula here, okay? So surface area equals 6x squared, where x is equal to the length of the side, so 6 times 17 squared. 6 times 17 squared is equal to, 174, or 34, oops, 34, not 43. 1734 inches squared. So that's our surface area. The surface area of the cube is 1734 inches squared. Okay, remember we like to have a sentence with word problems. So, I mean, it's the same process. The only difference is when it's a cubed root, you're looking for groups of 3 factors, whereas when it's a square root, you're looking for pairs of factors. Okay, so same procedure. It's going to take a bit of time. Going to have